welcome to the very short video on the difference between DNA and transcription and translation in prokaryotes and eukaryotes. So we're first going to talk about the difference in the structure between the prokaryotic genome and the eukaryotic genome. So first things is that obviously prokaryotes have DNA in the cytoplasm because they have their nucleus, and eukaryotes have their DNA in the nucleus. That's something that we knew since 10th grade. Okay. Prokaryotes, however, have circular chromosomes. When we get back from Christmas break, we're going to talk a little bit more about bacteria and their replication and how they sort of replicate their DNA and what consequences it has. They do not have linear chromosomes. Like us, they have circular chromosomes. And obviously, as we've seen, we have linear chromosomes. Prokaryotes have naked DNA. Now, what does that mean? Eukaryotic DNA is wrapped around something called histone proteins, which we're going to look at a little more after Christmas break. And the histone proteins actually help control which genes get turned on and off, which we're going to see again after Christmas break. But prokaryotes do not have their DNA wrapped around anything. It's simply just the DNA in a circle. It's not wrapped around histone proteins. And then, last but not least, prokaryotes have no introns. So all the DNA that is in the circular chromosome codes for a protein. And you think about it, that makes sense because prokaryotes or bacteria are small cells, much smaller than eukaryotic cells, and they don't want to waste space with junk DNA. And obviously, as we've seen with eukaryotes, it's the job of the spliceosome to splice out the introns and the exons or the coding DNA. Now, another difference that we're going to see in prokaryotes in transcription and translation is that in bacteria, transcription and translation happens simultaneously. The reason why this can happen is that the DNA is in the cytoplasm. So as soon as the DNA is transcribed, like as it's being transcribed, a ribosome can come on and hop on to the mRNA that's coming out as it's being transcribed by RNA polymerase, and it can start translating it before its transcription is even done. However, in eukaryotes, there's a sort of a time difference. We have our mRNA is made in our nucleus, and it has to travel when it's finished being made to the ribosome. Obviously, the other difference is there's no mRNA editing, there's no poly A tail, there's no GTP cap. And again, like I said, as soon as the transcription starts, translation also, as soon as there's the mRNA to translate, even if it's not finished yet, the ribosome will start translating the DNA even before the whole mRNA is made. The process happens simultaneously, therefore it also happens more quickly. So just to sort of summarize, there's a difference between transcription and translation in prokaryotes and eukaryotes. So there's no time, it's much faster in prokaryotes because there's no physical separation between the processes. In prokaryotes, as soon as the mRNA starts being transcribed, the ribosome can hop on and start translating it. Whereas in eukaryotes, this is not true. The mRNA has to be made, then it needs to be processed. We need to have our GTP cap, our poly A tail, and then we need to cut out the introns, and then it has to travel out of the nucleus to the ribosome. As a result, the process of protein synthesis is much faster in prokaryotes than eukaryotes. Now, the last thing I wanted to talk about, which there's no slide for, is one thing that's important and it's going to be a huge deal after Christmas break, is the process of replication, okay, which obviously is different from transcription and translation. Okay, in bacteria, bacteria replicate their DNA more often than us because they divide more often and they divide quicker. As a result, they have a greater chance for mutations. Okay, and that's going to be an important idea or concept when you come back from Christmas break. But that's the answer to question 3, is that they divide more often, and as a result, they can be placed if you kill all, like with antibacterial soap, that 1% can be remade, in a couple minutes. The 1% that survives. So because they divide more quickly, DNA polymerase has more chance to make mutations, and that's going to be important, an important concept when we come back from Christmas break. But that's the end of the video. Look, only a 5-minute video. I'll see you guys on Tuesday.